Hello and welcome to the lab. Today we're going to be focused on the measurement of oxygen consumption and carbon dioxide production. Today we're going to be using the Moxus Metabolic cart to make those measurements. And these measurements are important in this lab in order to indirectly measure metabolism. The Moxus Metabolic cart is a system that is used to measure pulmonary ventilation. It works by using tubes to directly expired air, as seen here, into a volume transducer that is powered by a turbo. This transducer is mounted on the air. The transducer is a device that turns the gas content in the air into electrical signals that can be visualized on the screen. The expired air arrives in the mixing chamber, where the samples of the air get taken, and then the transducer records the ratio of oxygen to carbon dioxide. The first step in using the system is calibration. Calibration is vital in order to obtain valid measures of gas exchange. Calibration shows the machine a standard or known value of gas, such as from the atmosphere or from a gas tank, which represents high O2 conditions. This allows the machine to have a reference for the measures that will be taken throughout the study. Calibration accounts for error and readjusts all values necessary to get the most accurate data. The first half of the calibration process is all about the hardware and the software calibration. The hardware calibration intends to show the Moxus system what a high oxygen situation looks like, using this gas tank here. And it also shows it what a low carbon dioxide situation looks like prior to the experiment. Alright, so the first thing we do here is open up the Moxus system on the computer. While it's loading, you can follow this tube down to the back and plug it in nice and tight to the computer. Once it's plugged in tight, open up the valve slowly and ensure that the valve's at 15 psi. Now we select Setup Study Calibration and click Calibrate Expired. So the next thing we do is switch these dials to calibrate and ensure that the numbers, as you can see here, are the same listed on the machine. Next you click Calibrate Air, and you go back down, and after some time you do the same thing, except this time you're going to ensure that the value reads 0.03. Next you click High O2 Mix, and while you're waiting you can come over with me and we'll build the mask. So to build the mask, you take this piece here and attach the spit valve. Next, take this piece and ensure that the valve is only going one way. And then next, you take the other valve and put it in. That way the inhaled air can go through. And you screw this piece on. And the final piece is the mouthpiece. It screws on like so. And when you're working out, you have this rubber mouthpiece attached, but for the calibration purpose, we're not going to attach that piece just yet. Now that this is done, click O2 and low, and wait. Next you click CO2 high, and again you wait. And then we click CO2 and low. Next, for the pneumatic calibration, you're going to attach the tubes to that way the air is directed into the system. The purpose of this part of the calibration is to provide the system with a predetermined mass flow of gases to be detected and measured. The syringe is used to pump air into the system in order to verify the performance of the transducers within the air inlet. Next, you click pneumatic calibration and pump with the syringe. The aim of this is to get 5 consecutive strokes within -1 and 1% air. Then you click verification and repeat that same process over again. This is what the athlete looks like as they're cycling. Once their muscles are doing work, the muscular contractions require oxygen, which is going to increase their oxygen intake and carbon dioxide production. You can see their values of respiration on the screen here. This is what the athlete's VO2 and VCO2 would look like as the exercise bout goes on. One limitation limitation, for example, is that there could be holes in the tubes, which would definitely skew the data and provide inaccurate readings of gas exchange. Another limitation is the use of a nose clip to block air going through the nose. If this is applied incorrectly, then the participant may breathe in or out of the nose, which also provides incorrect data. A final, very large limitation of using this method is that it only measures full body metabolism. This could be an issue if you're running a study that focuses on a smaller muscle group, as it cannot isolate that muscle's metabolism.